Hi viewers and welcome to the channel, and today we're looking at this macro and programming this macro, which allows us to move in 3D space and also in 2D space towards a target. And this is using vector maths. So if I run this, you'll see that the ball that just there has moved towards that cone. And if I transform the cone, that ball will move towards that cone no matter whereabouts it is, as long as that macro is running. Now this is good for animations because we may need to know in 3D space or 2D space a coordinate which could be moving or it could be randomly placed, and we need to move towards that coordinate, and we need to know the direction and the amount of movement that we need to move in that direction to get to that position. And this can be used for any of the workbenches that use placement in there, such as part design, sketch, draft, assemblies, etc. So stay tuned and we'll start programming this macro and explain the concept behind there. If you like this video, please hit a like and also subscribe to the channel. I also have a Ko-Fi site where you can actually donate to my contributions to the community, and that's at ko-fi.com/mang0. So I'm going to start by creating a new scene or a new document, and I'm going to show you how to do this in 2D space for starters, because it's much easier to understand in there, and then we'll move into 3D afterwards. So I'm going to do it in the sketcher. I could do it in the draft, but I'm going to do it in the sketcher. So I'm going to create a new sketch. XY plane's fine. And what I'm going to do is I'm going to create two circles in the XY plane, and this is the circle that I want to move, and this one is the circle that I want to reach. So what I want to do is, let's make these slightly different in size. So I want to get the small circle into the large one. So over time, if this was my animation, I want this to move to that point. So if you're thinking this in some kind of mechanical movement or something like that, then you may want to move an object to a certain vector. It doesn't have to be an object, it can be a vector. These all run on a vector based system, and we can get that into that in a minute. I'm going to bring up a few panels so I can show you what's going on. So a few panels, and I'm going to have the Python console. Right, I've just brought the text up a bit so we can actually see what's going on. So in here we've got this app.getDocument unnamed getObject sketch. So that's the main sketch it's getting. I can assign that to a variable, so I'm going to call my variable sketch equals that. So now we've done that, what that means, clear console, and if I type in sketch, it'll come back as sketcher sketch object. Now if I move one of these points, so this circle and that point in the middle, you can see it's got move point 0, 3. So I'm going to grab that point. So if I do sketch dot get point and 0, 3, when I hit enter, you can see it's coming back as a vector. So vector is x, y, z. And with vector, there's vector maths. So with the vector, if I take that again, sketch.getPoint, and this is my, say we call this our actor and this our destination or our target. So I'm going to assign actor, which is just a variable name, I'm just using the variable name, equals sketcher, the sketcher object, which is sketch, which I assign that dot get point 0, 3, and type in actor now, and I've got my vector. The trouble is, if I move this, obviously if I type in actor again, it won't take the new placement. We're still referencing the old placement there, so we would have to refresh that. We don't have to worry about that. What I want to know is how far away this point is to here, and we can do that by actor, which is now our vector, dot distance. and there should be a distance to vector. Spell it correctly. Distance to point, there we go. Distance to point, not distance to point vector. And then we can actually pass in here the other one, this one here, which should be there we go, out dot 1 3. So we've got 0 3 and 1 3. So if we type in actor dot distance to point and then use our other point, which is get sketch, so we could use sketch in here, sketch dot get point, and then it's 1 3. That will return a distance, and that's how far. So that from there to there is the distance. Now when you've done that, that means you can do collision detections, because when they become into, say, this far away, the distance will be shorter. So if we did that, so sketch dot get point, and that was 0 3 dot distance to point, and then sketch, so I'm pulling in the other point dot get point, that's 1 3 0, put 0 1 there, 0 3, that should be 1 3. Close one brace, close the other, and that should be alright. Then it's showing that one's 6. So we can say if we're in between a certain distance, say if we're under 5, distance under 5, then we've collided, or the distance is the length or diameter of this circle, and and we're looking at the diameters of these circles. And if they touch, in matter of fact, if we use a bit of math, we can find out the distance of way those are together. And that's how you would do the collision detection with the distance in there. But what we want to do is actually move these points together. And we can do that quite easily. And I'm going to create a macro to do that. So I'm going to do it in 2D space. And I can come into macros. And we're going to create a new one in here. So we hit create, and I'm going to call this move object to vector. So the first thing I'm going to set up in here is I'm going to harvest these two vectors. So in the center here is a vector, in the center here is a vector. That's how it's positioned. So we roll over there and roll over that point. You can see if you cast your eyes down to the bottom left, that tells you whereabouts that is placed. That's a vector. So the first thing we're going to do is use this get document on a sketch, and we'll use the get point as well. So sketch equals that. So we've got the actual main sketch object. Then we've got to get that vector in the sketch. So this one here, and that was, if I move that, move point, so we do get point on 0 3, and that will pick that up. If we pick the point up, we pick the circle up. Simple as that. So we come back and we do our, again I'm going to call it actor, so there's a thing that we're actually moving. The actor is on the stage, it performs, so we want the actor to perform by moving to somewhere else on the stage. That's how you normally talk about it within animation or when you're programming animation. The thing that you move is the actor. The things that it collides with or it's got to go towards are the obstacles or targets. So actor equals sketch dot, we use the get point because we want that vector, and it was 0, 3, wasn't it? 0, 3. Now I'm going to use the word destination, or sorry, target for the other one. So target equals sketch dot get point, and that's 1, 3 should be. Yeah, 1, 3. So what I've done is just signed up the actor and the target, so I can do something with them. And what we're looking to do is moving the actor towards the target. So if you was doing this in animation, then each loop you go around the animation, you want to move one of your items in your animation. So I'm going to move this circle here. If this was in 3D space, it might be a body. If it was an assembly, it might be part of the assembly. It's totally up to you, but the concept is the same, and the way you program it is basically the same as well. So I'm going to move this towards this target over here. I've got that, actor and target. Now I want to say how far I want to move this. How many units that I want to move it towards that target. And we're just going to call that a distance. Well, actually a speed. So let's call it a speed. I'm going to say that's going to equal to something like, I don't know, 30. So we're going to move 30 units. That's the speed what we're going to move to. So each time we run the macro, it's going to move by 30 units towards that target. We also, when we're moving stuff, we have to find out what direction the target is in. And that is quite easily done. So I'm going to use the variable direction. And it's as simple as minusing one vector from the other. And that finds out, using vector maths, whereabouts in 3D space that is directioned. What I want to say is, direction do I need to travel in to get to my target? And the direction will equal, so the target vector minus the actor vector. So in this case, well, the actor and the target are both vectors. So direction equals the target minus the actor. And what will be nice is if I output these as well, we can then see what actually happens. So FreeCad .console .print message, and the first one we need is the actor. So that's the actor vector. And if we run that, when we run it, you can see it's coming up vector. And what we need is to show that on our panels. So panels, and we want the report view. Let's clear that. So we run that now. We get the vector. So that's the actor vector. So what I'm going to do is place that in a nice string plus, and write that in str so it converts it to a string. And also we need a plus, and we need a new line character on here. So there we go, /n for the new line. So each time I run that, we get the actor vector come up saying whereabout it is. That's cool. So that's all good. So we've got that there. I'm going to copy that line and move that down to the target as well. So target vector, let's be descriptive. That's the target in there. We've got actor vector and target vector. We also want the speed, which we're okay with. We know what the speed is, and I'm going to also print the direction as well. So direction equals that direction there. So we can see what actually comes out of here. There we go, let's spell those correctly. There we go. So now we can see what those are. So when we run them, you can see the actor vector, the target vector, and the direction, which is a vector as well. Now so that shows us the direction that we need to move towards that target. Now we've got to normalize that vector. So if we come in here and do direction dot normalize with a Z, and what I do is clear that, you can see how that vector has changed there. So what does it mean to normalize a vector? So we've got our vector and we've found out the distance between the actor and the target, and that pulls back a vector, and that distance in a whole number, as in not x, y, z, the actual distance away in units, could be around about 40, 36. We're not quite sure because we've got a vector back. We need that vector that's come back to be the same if we was casting the distance just 1 unit. So if we had our target was away 1 unit, then what would our vector look like in that situation? So that's what normalization as a vector is. It's taking that vector and saying, right, if we're 1 away, what would it look like? And then when we times that by a distance of travel, then we get the amount that we need to move in that direction to go towards the target. So our next step is to actually do the movement. And to calculate the movement, I'm going to use the variable called movement. And I'm going to equal that to the direction times the distance I want to travel, or the speed. So we've got our movement, which is direction times the speed. Let's output that movement so we know what it equals. We'll place direction with movement in there. So you can see now when I run it, the movement is a new vector which has been calculated. Remember, we're using 30 for the speed, so that's going to be quite a difference between what it was before, where our actor was before, and the amount that we're going to progress. So we can see the actor vector there is 0.2. It's now 26.6, and the y is minus 0.1. We're now looking at minus 13. So that's the amount of movement that we need to add on. So we're going to add that on to the actor, and we're going to use the new, because we're calculating the new position for this, equals the current position, so the actor, and we need to plus the movement to that, and we're going to also output that to screen. So let's copy that console print message and change the movement to new position, and that should show the new position of the actor. And now you can see the new position here, so 26.9 minus 13, and our actor old position, which was 0.2, and minus 0.1. So 30 is quite a big step. So let's change this to something like 5. clear that. So the original 0.28 minus 0.1, and now we've got 4.7 and minus 2.4. So I've accidentally moved that. Let's put that back. So that's clear. So I've cleared that out. And what I want to do is move that sketch now. So I'm going to move that circle towards here. To do that, we've got the sketch, which is the app.getDocument unnamed.getObject sketch. If we come back to our sketch, if I just move this slightly, you can see we've got the move point, which is 0, 3, and then followed by a vector. So we should be able to do sketch.movePoint 0, 3, followed by the new position, which is a vector. So when we run this now, we should see this advance towards our target. Do it a couple of times. So it's starting to move towards that target. And just a few more. It gets there. So let's put it back and just increase that speed to 30. And what I'm going to do, actually what I will do, is just do a small loop first and then move this to a proper timer loop. So for instance here, if I did for, now we don't need a variable, so I'm going to use underscore in range, because we're not going to access a variable for this. And the range I'm going to be using is, let's just put down a new line, there we go. I'm going to move it 100 times. Let's go for 10 times first to be safe. 10 times. And we're going to be doing most of this in here, but I'm going to put the sketch outside the loop because we don't need to redefine that. We need the active sketch.getPoint because that halves the vector from there. I'm going to remove all these messages because we don't need them. So we'll see the point move. Speed I'm going to put outside the loop because we don't need to redefine that each time we go around. Target I need to redefine. Movement and sketch move. So all of these, just highlighting, and I'll press the tab to tab them over. That means they run inside that loop. Now this will lock the GUI up because it's bad practices to do it this way, but this is just a one-off to try it. So we can use GUI.update GUI in here, and that will release the GUI so we can actually see what's going on. So I'm just going to clear this now and run. And we've missed this actually. Let's bring this back. And I'm going to increase, because it's moving too fast, I'm just going to put 0.3 in here. And let's do the range up to something like 1000. And there you can see how that's moving towards the target. And once it's in the target, then we probably would need a way to stop this macro there. So that's how you would move that towards that target in steps of 0.3. And adjusting the actual vector to get to there, we're calculating the vector, the distance between two vectors to get to there. Obviously you won't do it in a for loop, you do it on an animation timer to make it much more robust in there. You could do it this way if you're just playing about with the animation, but it tends to cause a few problems. You can lock up your GUI, you can lock up your animation if you put too many zeros in here, obviously. So let's wrap this in something that we can reuse. So I'm going to take this movement and place this in a separate method. So I'm going to call the method def movement, and this is going to take a actor and a target. So this is the start of actually something called refactoring, molding this into a separate piece of code that can be reused and cleaned up, ready to place inside our class. So I'm going to tab over, so we're inside our function now, or our method. I'm going to be calling this method with our actor and target, and that's going to be progressing that one step each time. And I'm going to place all of this code inside there, leaving the actor and the target outside. I'll show you the reason for that in a minute. So remember, the tabbing is essential in there. So if we tab over, that means that we're inside this method. So we can call this now, and if I call it here and type in movement, and we pass in, because this takes an actor and a target, actor, comma, target, then that will call that method. What I want to do really is bring this, cut that out and bring it below. So we're placing it below, so this is defined before we start running our code. To run that now, we haven't got any problems. Go back and let's move that out of the way, and there it is. So that's moving now towards the target. So we're still the same code, but we just neatened it up. I'm calling it in here. That means we can actually move this into a class much easier, because we'll use this as a method in the class. What we're going to do now is take this code and create a scene in the part design or the part, and see how this transforms to 3D space. So first of all, I'm going to jump into the part design, or actually I might use the part in this area, just because we've got basic shapes in there that we can use. I'm going to create a new scene or a new document, and we're going to see how this translates to 3D space. So I'm in the part, and the actor I'm going to use as a sphere, and our destination I'm going to use as a cone, and let's just separate those a bit. So right click and transform on the cone, and we're going to place it somewhere over here. Let's zoom out a bit so we've got a bit of space. There we go. So what I want to do is move the actor, our sphere, towards the obstacle or target, our cone. So let's see the differences between the process. Well, we've got the cone, so I need to pick up the cone. So I'm just going to, we've got the placement open down here, and I'm just going to move the placement, and we can see by moving the placement we move the object. And also, now we've moved the placement, we can actually get the object as well. So FreeCad.getDocument unnamed get object sphere, and we've got the placement there as well. So I'm just going to pick up the sphere first. So I'm going to just create a variable, say let's get rid of this report view because we don't want that. So we've got a bit more room to work with, and I'm just going to increase this a bit. I'm going to type in my sphere, call it what you want, which is the actor anyway. So equals, and then we'll paste that in. So my sphere now equals the sphere. My sphere's also got a placement, as we saw, and you got placement, position, your role. Okay, so what else we got in? We've got base, and that's a vector of 0, 0, 0, which is correct because that's sitting at 0 position. So if we change the placement position and place it somewhere over there, let's try that again, and that's clear this, and we want my sphere.placement.base -800. So that's our placement there. Now we should be able to get because that's a vector, we should have the same command to do a distance to the other vector. So I obviously want to pick up this cone as well. So we're just going to click on the cone and just move it slightly. And that's the command to picking up the cone. So just grab the cone there. Let's clear that a second. So my cone equals that, and we should be able to get a placement on there as well. Placement dot base, which is 51. So if we go for my sphere dot placement dot base dot, and then we should have distance, there we go, distance to point, and then pass in my cone dot placement dot base. That should give me a distance of 59. Okay, so that's our distance. So we've got the distance. Now we should also get my sphere dot placement, and there should be a move in here, hopefully. There we go, move. Let's see what that takes. Moves placement along with the vector. The thing is, what does that take? Because the previous one was moved to a point. This is just moving it along a vector. So if we do move let's move 12, 0, 0. So where's that moved? That didn't do much, so it's saying unexpected indent in there, and we've indented that by accident. There we go, let's move that back. Takes exactly one argument, 3 given, so that is, we've passed the XY position, and that needs to be a vector. So app.vector, and we should be able to place it like that. Yeah, so that's moving, and that's moving actually 12 at a time. So we do -12 on that one, and we can get back. So that means that when we do the movement, got the movement equals direction dot speed, and the new position equals the active vector plus the movement. We don't need to do that, we just need to use the new position as the movement, because we're actually using that here by adding a new position plus the movement. This is just the movement, so we don't need to calculate the new position, we just need to pass the movement when we actually move. So we'll keep that in mind when we come to do this. I think that's all that we need. Right, so let's convert this code to actually run this instead of the actual sketch. So we'll clear that. Let's have a look at our code. So first of all, we've got this sketch equals app.getDocument unnamed.getObjectSketch. We're not getting the sketch anymore, we're going to get the 2 objects. So our 2 objects was my sphere and my cone. Remember that if we want to reference it, we'll just move it and we'll get the reference to the cone, and we can use that for the sphere as well. So FreeCad.get document unnamed.get object. Obviously this is the document here. You could use .get active document in here instead of this one, instead of this, and that will get the active document. Get so FreeCad dot as active document. There we go, active document. That gets that, and then get object cone. And that will bring that in there. So let's use that. And then if we change the name of the document or save it, then that doesn't matter. So let's go to our macro and change that. So we want the cone, which is going to be our target. FreeCad.activeDocument.get object cone, and we want because the target is a vector, I'm going to change the name of these. The movement actor, rather than using actor, I'm going to use something a bit more descriptive. This is the actor vector and the target vector. So all of those need to change. That makes it simpler because I'll be using target to actually call the object itself rather than the vector. So movement, direction times speed, actor vector. Just to update these, and actor, we don't have to worry about those. Actually we do, so actor vector. And lastly, so all we've done is change actor to actor vector in here, and we're going to set the target to the actual object. So the target equals the cone, and obviously we need the actor, which is going to equal the sphere. And it's called sphere, isn't it? If I roll over it, internal name sphere, yeah. So we've got the actor and the target, and if we're doing that, let's copy that and paste it in here. We need the actor dot placement dot base as the vector. So that command there we're going to use in here. So actor vector equals that, and the target vector is the same, but we're using the target rather than the actor. So let's change that to target. So that places that in there. So we're reaping those. Now if we come in here, we're doing this movement equals direction times speed, and as we saw before, the new position, we don't need to add the active vector to that. So that we do need in here. So I'm just going to take this new position variable, going to get rid of that line, and actually if I put new position, rename this new position, it's going to get confusing. So this movement I'm just going to place in here, and this is the wrong command again. So we wanted in here, let's get rid of this, just want movement in there, and we want to move the actor dot placement, and it was dot move in there, and the movement. So let's just check that, actor dot placement dot move, and that took the vector. This movement was direction times speed. So that movement is a vector that's coming in. And that should do us. So let's get rid of that. And let's clear this. And give that a go. So at the moment they're that far apart. Hit run and come back in, and you can see that's moving to there. That's moved and positioned itself there. So we'll quickly change this to, let's change this sphere back. And where do we want it positioned? Stick it back to 0. And what I'm going to do, get object placement equals, to copy that line, dot placement, come in here, and I'm going to set actor dot placement equals app dot placement, and that will just place it in the right position when we start. So hit go now, and you can see it's moving. Let's move into position. The macro is still running, and we can give that another go as well. There we go. So that's how simple it is to convert that from the sketch to the part. You can see the very similar commands that are used in there. The calculation is exactly the same. The only thing that we did differently is that the movement command is the amount we want to move rather than the placement of what we want to move. Before, this was taking an exact position in 3D space. This just takes a vector, the amount we want to increase or decrease along the X, Y and Z axis. What you would normally do for this is place this in the proper animation loop. So we place it into a timer, or even create a window that controls the timer and place it into there. So you're still placing it into a timer, but this way we're doing it here can be seen as bad practices because we're on something called the same thread as the GUI. This is the reason why we're doing the GUI.update. This is running on the GUI thread, so the macro is running on the GUI thread. If we create a timer, what happens is that the main code runs on the GUI thread, and a thread is spawned for the timer that runs it independently of the GUI thread. And that means that we don't lock up the GUI thread, so we don't have to do this GUI.update each time. And on my channel shortly, perhaps next week, I will actually go through the different types of animation loops you can do. So we'll go through the simplest one like this, and we'll work our way up to the timer and doing one with a window as well. So that will be on my channel, and we'll refer back to that in more videos because I'm going to be doing more videos around animation and the different types of movement that you can do, and some tips and tricks around that. So look out for that, and I'll see you again soon. If you like what you're seeing, please subscribe to my site, and also I have a Ko-Fi site where you can actually donate a few pence or a few pounds, dollars, or whatever your currency is, and that's at ko-fi.com/mang0, and there you'll be able to help me fund my site, and all the money that I actually get from any funds will actually get pushed back into the channel. Thanks a lot for watching and subscribing. I'll see you next time.